Hi everyone, this is Dr. K. Kannan, faculty from ECE, RMPCET. Through this lecture today, I am going to discuss about the heterodyne procedure in AM and FM. So this heterodyne procedure in AM and FM play an important role to find out the noise performance. So next one, we are going to talk about the AM super heterodyne receiver. Okay, so before going to the topic of heterodyning in receiver, we have to know about what is the basic requirements of any receiver. So a radio receiver is used to receive both AM and FM of corresponding bandwidth. Then the detection of AM is done by the method is called envelope detection, and the detection in FM is done by the method is called frequency discrimination. So before entering to that, what is the basic requirements we have to maintain, or we have the important requirement to go for the receiver. First one, it should be a cost effective, and the second one, it should receive both AM and FM signal. Then the receiver should be able to tune and amplify the desired station, and it should be an ability to reject the unwanted station, that is unwanted frequency. Then the demodulation has to be done in all the station signals, so whatever the carrier frequency. So these are all the important five criteria or five requirements must satisfy any radio receiver when in AM and FM. So for this requirement to get fulfilled, the tuner circuit and the mixer circuit should be very effective. So when you are going to meet this requirement, then we have to we have to design a system in such a way that the tuner circuit and mixer circuit must be very effective. Then super heterodyne receiver. So the name is called super heterodyne, means it is a multiplication. Yeah, super heterodyne receiver uses signal mixing to convert the input radio signal, that is in RF frequency, into a steady state intermediate frequency is called IF. So that can be worked with more easily than your original radio signal that has a different frequency depending upon the station of the broadcasting. The intermediate frequency, that is IF signal, is then amplified by the strip of amplifier, that is more than one IF amplifier, and then the output of this amplifier is fed into detector circuit, where the output is obtained from the input of IF. Then finally it should be amplified by the audio amplifier. That amplified output is given to speaker. So most of the time the AM receiver found today are of super heterodyne because they allow for the use of high selectivity filters in their intermediate frequency IF stages, and they have higher sensitivity, that is based on the structure of the antenna or the normal the hardware of the antenna, that is a ferrite rod antenna can be used. So due to the filters in the IF stage, which helps them in getting rid of unwanted RF signals. Also the IF amplifier strip providing higher gain and a good strong signal response because of they are using automatic AGC, that is automatic gain control in amplifier and AC of operation. So here the control of volume and control of power and the tuning term we are going to talk about. This is the entire block diagram of super heterodyne receiver. So here look at the diagram. First one, we are having the antenna. That antenna output is given to RF filter, that is radio frequency filter. So this filter activates only the radio frequency. So it will allow only the radio frequency, not below or not above. Then that output of RF filter is given to mixer. So mixer mixing two signal. One is from the RF filter and another one from the local oscillator signal. So local oscillator signal always should be higher than the RF filter. So this will be using as a circuit which is used for in transmitter side also, that's it is called a local oscillator. So the local oscillator input and the RF filter input is getting mixed by the mixer, then mixer output is given to first IF filter. So here the frequency range is 1455 kilohertz. So this will allow the low frequency in the range of 1.4 1455 kilohertz. So the output of this first IF amplifier is given to first IF filter is given to IF amplifier, where some the signal getting amplified. Then this amplified signal is given to again second IF filter. Then the filter output is given to second IF amplifier. Then it is third IF filter, and finally given to detector. So from the detector output there is a feedback. From the detector output, one part of the signal is given to first IF amplifier. Because of this feedback, we are correcting the output at the detector output. So this detector output is given to amplifier for the audio frequency. So input is radio frequency and the output of detector is is a audio frequency, that is a low frequency. So to convert that RF into low frequency, we go for the diode detector, where we are using diode as a down conversion. Then the amplified output of audio amplifier is given to speaker. Then from the speaker we will get it the output. So here the audio amplifier, the frequency is, that is in terms of audio frequency, in terms of kilohertz, right? So this is a general block diagram of super heterodyne receiver. So then we will talk about each and every block of your AM superconductor receiver. So first one, RF filter. So this RF filter induced, it contains some coil and a capacitor that will control the resonant frequency. So because here we are using the ferrite rod as an antenna, so that we are going to get the resonant frequency of the coil and the capacitor that is equivalent to the corresponding station carrier frequency. Then we have a heterodyne local oscillator. This heterodyne local oscillator, it is called it is a second block, and here we are going to talk about the mixing, that is input frequency from RF and the output from the local oscillator. So that here we are going to mixing, so that it is called heterodyne local oscillator. Here the frequency range is around 445 kilohertz of IF frequency we are using. Then the next one, it is a mixer. The third block is called a mixer, where the RF signal and the local oscillator signal is fed to the mixer to produce the desired intermediate frequency. So the mixer found in common AM receiver output, that is the sum and the difference of the input of LO and local oscillator and the RF signal. Okay, so most often in simple transistor radios, the heterodyne and the mixer are made using one transistor frequencies. Then we have first IF amplifier. So the fourth block of the given block diagram is for the IF filter. So most of the time in AM receiver, so the resonant circuit is placed in the collector of the mixer transistor with the resonant frequency that is equivalent to intermediate frequency. So its purpose is to filter off all the signals with a frequency different from the IM frequency. So different from the IF frequency because those signals are unwanted mixing product and do not carry the audio signal to the station, so that we want to listen unnecessary signal, so that we are going to remove it. Then we have IF amplifier. The fifth block is IF amplifier. Here we are getting the gain of 50 to 100 in each IF stages. The turn it is common if the gain is very high. Then the distortion also taking place because of the gain improvement, and sometimes the gain is maximum and sometimes you will get a minimum gain also. So here the IF filter are very close to each other and not properly shielded, and parasitic oscillation also taking place. So the amplifier is controlled by automatic gain control, automatic gain control circuit, or we can say the AGC, the voltage from the demodulator. So that is automatic gain control lowers the gain of the stages, causing the output signal to be roughly the same and regardless of the input signal amplitude. Then the second IF filter, this is sixth block of the circuit, where just like the what the first IF filter is doing, the same thing only it will do, so that we can improve the selectivity of the receiver by using second IF filter. Then second IF amplifier, this is seventh block. So what the first IF amplifiers do in the circuit, the same thing only here. Here we are going to have the many more AGC control we can get it by by doing that one. We are going to get some increment of the distortion. Then the third IF filter, it only lets the signal of the IF frequency, so that we are improving the selectivity of the signal coming from the second IF amplifier. Then we have the signal detector. So this is a ninth block according to the diagram in the form of diode. This is called a diode detector, where germanium diode we are using, or something we have the some kind of transistor type of diode detector also we are using. So here what it will do, it will do the demodulation from the signal, that is demodulated output is coming to the input of the detector. The detector output, it is our original message signals, right? So that what we are going to do, there is the ripple count also, ripple component also will be there, so that by using the filtering operation we can filter out, and finally we are going to get the signal. Then the output of the signal is signal from the detector is given to audio amplifier. This is a 10th block, so it will amplify the signal of audio frequency. That audio amplifier is kept below the before the speaker. Then the speaker, the last block, where we are using the speaker of 8 ohms with wattage is 0.5 watt. The output the outputs audio to the user. The speaker is sometimes connected to the audio amplifier through the headphone. Then what is the advantages of super Heterodyne receiver? So this super Heterodyne receiver, it converts high frequency to low frequency, and all the process, that is the IF amplification and removal and amplifiers, filters, that and all operated in only lower frequencies. And because of this low frequency, it will be available anywhere, and we can have the low frequency as well as high frequency also we can get it. Then the amplification, that is easy to filter IF signal compared to the RF signal. Then third one, the sensitivity of the device is somewhat good compared to the heterodyne receiver architecture. And fourth one, heterodyne uses single conversion, and the super heterodyne uses the double conversion. So both the conversion also it is possible. So it will prevent the noise foldover due to the use of two IF frequency before conversion to the pass band. Then what is the drawback? So here we are using the local oscillator, that is LOS and RF mixer, to convert the signal from RF to IF before conversion to the passband. So that we are going to have some the component cost is going to higher. The next one, the filter also needed to remove any leakages from the local oscillator, and this will create some unwanted frequency acceleration, so that we are going to have the image rejection, that is prevent image frequency. This also increase the cost as well as the complexity of the receiver. Thank you all. Thank you for watching this video.